In today's session, we will be covering about how to use feature flags in order to develop faster, release safely, and maximize impact using feature flags as well as experimentation. Without much delay, let's jump into how we can develop faster. Next slide, please. Let's dial back in time and try to see how engineering development velocity has changed over the last several years. In the 90s, we had companies such as Microsoft releasing software every few years. So you would see a new Windows OS version or Microsoft version coming out every few years. Then came Salesforce and its cloud software in the 2000s. Salesforce came in with 2 releases per year, and that deployment frequency was rare and a huge improvement over what was normal. As companies have continued to evolve their technologies and automations, we saw that drop to monthly, weekly, and even daily deploys. In 2015, when I joined Cisco and the team said they did daily deployments, it was an aha moment for me. Today at Split, on some of my teams, we do multiple deployments a day. Such has been the change in deployment and feature release velocity. There have been several factors, both in terms of processes and technology, that have made this possible. Let's first look at what those process changes have been. Next. So a rapid development velocity has been possible because a change in the operating mode for product teams. Feature development and iteration has drastically changed over the years. We've moved from having giant waterfall releases to identifying what an MVP would be, a small piece of a larger vision that would bring value to the customer and then allow for rapid iterations from there. With continuous customer feedback. As you all know, customer feedback is a guiding force for growth of any company, and faster the feedback loops, then the teams are able to get that feedback quickly, as well as they're able to incorporate that feedback and get it right soon from a customer's point of view. As the processes have evolved, so have the technologies that need to support these processes. There has been the cloud evolution. There have been tremendous improvements in DevOps technologies, and that, coupled with a strong switch to automation, has enabled this. Feature flags is a critical component of this evolution. Next slide. So what are feature flags? To put it simply, feature flags are if-else controls in the code that enable toggling features at runtime without the need to make a deploy. But feature flags are not just limited to if-else statement. They can be as simple as an on-off switch. They could also be used to experiment through multivariate or A/B testing, or it could be a fully dynamic configuration that could be used to change the behavior of your system at runtime without having to make a code change. Feature flags make development faster and safer. They mitigate risks by reducing the blast radius, and they provide the ability to kill buggy features without the need to roll back your deployments or make hot fixes. Let us take a look at how feature flags have actually helped streamline processes in the DevOps lifecycle. So here you have a typical stages in DevOps. So in the dev stage of this DevOps lifecycle, you will see that feature flags enable trunk-based development. So if you're not familiar with what a trunk-based development is, this is a version control management style where developers make changes frequently to one core branch called the feature branch or called the main branch, without having the need to maintain multiple feature branches for every feature that they are working on. So this actually makes development easier and faster because now you just have a single branch. You don't have to worry about maintaining multiple different branches and then trying to merge from these different feature branches, because these having multiple feature branches in the past have always caused a lot of pain, which merge conflicts and what we used to call as merge hell. But in order to leverage this trunk-based development, it is important to be able to separate the deploy from release. And feature flags provide the ability to do it. And the reason being that, when you have a code behind a feature flag, which is in an off state, it is pretty much the same as having a code that is not deployed in the production environment. So that way, you get a clear separation between what you're pushing into your repo and what's getting pushed out from your repo into your deployment environment. Moving from the coding cycle to build and testing, trunk-based development is the foundation for continuous integration. That's because continuous integration is based on the philosophy that you would have a single code branch that is essentially your source of truth of the latest code. And then all your integration tests are running against this branch. And when your integration tests pass, then you can consider that that branch is pretty much ready for deployment. So without your trunk-based development, you wouldn't be able to have your continuous integration or a good continuous integration process. So feature flags also, moving on from the integration to the deploy and release cycle. So feature flags provide the right kind of guardrails for continuous delivery. I'm going to hold off on this for a bit and we'll come back to this. Moving on to the post-deployment stage of the DevOps lifecycle. So feature flags help reduce the blast radius by providing the ability to progressively roll out features, conduct experiments, and reduce the minimum time to resolve through incidents by giving a kill switch to quickly turn off any offending changes that may get into your production environment. So as you can see, feature flags are very, very critical in order to keep the ball moving in the different stages of the DevOps lifecycle. And also, if you want to establish a mature DevOps process, then they become a critical element of this. Next slide. Moving on from developing faster, right? So this kind of we kind of spoke about how things can move quickly by having feature flags. Now let's talk a little about how feature flags make it easy to release. I told you earlier that I'm going to hold off on continuous delivery model. So let me come to that now. So in a traditional continuous delivery model, you would typically deploy changes to a pre-prod environment, then validate those changes either through automated or manual testing in that environment, and then deploy to production. However, there are several challenges with that. First, there is limited validation of the features. Most pre-prod environments, they're not at the same scale and they don't have the same configuration as the prod environments. So they're not a true reflection of how the feature release would impact production environment. The second thing, yes, feature flags provide an on-off way of toggling your release. However, based on that, the feature is released to 100% of your users. So if there is buggy code, then the blast radius of the impact is large. It affects all the users. Complex features can also have several dependencies, especially in modern modular architectures. And a single module or service having an issue could essentially impact multiple services. Yes, in either of these cases, you may argue that we can use other techniques such as canary deployments or release to a subset of users to reduce the blast radius. While this definitely helps, it is still limited as these techniques are targeting a randomized set of users over which you don't have control. So how does feature flag help? So feature flags, advanced systems like Split allow for a progressive delivery of features. So you would essentially start off with a small, Annie, can you please, yeah, thank you. So you would actually start off with a small subset of users, which could potentially just be your developers who are developing those features. And then once you feel comfortable, it would go to the next stage, which is probably your company. In fact, we do that at Split. So initially we start off with our set of the team that's actually developing the features. And once we feel confident, we actually roll it out to our own company users so that our colleagues can essentially validate it and test the features. After that, we feel confident. We start to do alpha and beta releases, where we have a subset of our customers who sign up for this, and then they're able to use these features and give us early feedback. As part of the beta release, we can also test for scalability and other issues. And in case things go wrong, we just roll back the features, make the fixes, start over again, and start to roll out the features again. And eventually, when we feel fully confident that things are fine and we are ready to release, then we go out for all our customers. So this essentially helps us in a way where we have good control over how things are being rolled out. Talking about a few different use cases that we've actually internally used in Split in order to safely release the feature flags. Next slide. So first, removing of dead code. Traditionally, when we want to remove code, we would end up, adding a log and just kind of monitoring that to see whether, that log gets hit. And if at all, then we know that the code is still being used, so we cannot remove the code. So we would just wait for that usage to go away. But there is a side effect of this. Depending on how much traffic that code segment is getting, you may end up with a number of logs, right? And as the log volume increases, we all know that it's not a great thing. So what is the alternative? The alternative would essentially be where you end up with using a feature flag around your log, and then you start to do this progressive delivery. So you maybe increase it to 1% of traffic, and then see if the log shows up. And if the log shows up, you know that your system is still being used, or that code segment is still being used. So you just remove the log and let the code stay. If you don't, then progressively roll it out through several different stages until you feel until you've rolled out 100%, and then you feel confident that that particular code is not getting any traffic. And at that point, you can essentially feel confident about removing your dead code. The second use case here is stress testing systems. So going back to one of the points I made earlier, that our test infrastructure is usually not the same scale as that of our production. How do you stress test any scalability improvements you have made? Yes, of course, you can scale your test environment to production and generate artificial traffic. This is both expensive and, again, not a true reflection of customer request patterns. Instead, then why not stress test this in production? You can use a feature flag to mirror your traffic to new improvements and collect the load and performance metrics you want in an async fashion. This would not affect your customers, but at the same time, you would be able to collect all the metrics you need to feel confident that your intended scalability improvements is working as expected, and you can roll it out to your customers. The third use case is about checking parity. It's related to the stress test of systems. How do you make sure that any new improvements you're making also maintains parity with what the old results were? Use a feature flag. Test the parity between your old and new logic. If they start to differ, log it. You can then go back and validate what's going on, fix it, and roll it back again. So we actually have a great presentation on the specific use cases that you can use using feature flags by Joy Eberts, who's one of our principal engineers. And this is available on our website. So for that and more content related to feature flags, I would highly recommend you to take a look at the developer resources on our website. We've talked a lot about feature flags so far and about how they help us release safely. How about we take this up a notch and add some ops data to it so that we can become a little more data-driven in our decisions? So to talk to you about that, I'll be handing it over to Annie.
All right. So yeah, when we talk about releasing safely, as Trish walked through, feature flags can go a long way, but data is ultimately what's going to make the difference here. So first of all, we talked about testing and production. We know that staging is not always representative of production. There's different data at a different scale. And we've all probably experienced that no matter how much you test and you think you have things perfect, inevitably something someday will go wrong in production. So the data married with the feature flags will give us that specificity so we can understand what went wrong and by how much on real traffic. This enables you to ultimately turn off problem features. So gone are the days where you have to roll back an entire application version, because with feature flags and data, you can actually isolate which specific feature is causing the issue, take immediate action, and give your teams breathing room to resolve that problem. And then finally, there are opportunities to let the data work for you. So let's say you have a very important metric like revenue. You want to be absolutely certain that nothing you release is going to negatively impact revenue. You can actually set guardrail thresholds at which that cost of the feature is too high. And as soon as the thresholds hit, trigger an alert and turn off the feature in production. Now, when you're using feature flags and data, defining your guardrail metrics is really important. So some common examples of guardrail metrics include support tickets, app crashes, page load time, API response time. This is really just naming a few, and you probably all have common guardrail metrics that you're already tracking and monitoring day to day. Tools that offer feature flags paired with data probably support also a host of integrations so that you can seamlessly connect the data you care about most and the data that you're already monitoring into the feature flagging platform. And guardrails don't have to be system or performance metrics specifically, but they can also be a combination of those along with financial, user experience, and or strategic metrics. So in the example I shared earlier, you might want to protect against a drop in revenue. In that case, that would be a guardrail metric for a specific feature that you're rolling out. So that leads us to taking the next step with data, which is actually maximizing the impact of the features that you're going to work on. So let's look at an example where you're testing a new signup flow. And let's say you're a growth product manager and you're trying to optimize your mobile app signups. So you've worked with your designers and your engineers to come up with a couple of possible flows. You can see here, there's on the left, there's option A, which is adding a create new account link below the login button. And then there's option B, which is adding another button next to the login button that enables you to sign up directly with that username and password. Now, you might have a hypothesis about which of these options is better, but ultimately you want to validate that with real data. So running this as an A/B test on a sample of users can give you more insight about which version might lead to higher signup conversions, which is your success metric in this case, and how conversion might differ between different cohorts of your users. So in this example, you'll see that the signup button was the winner here with 30% higher impact. And so you're able to use that data to make a decision about which flow to ultimately roll out to all of your customers. Now, you might be thinking, well, I can collect data about clicks and just analyze that data in an APM tool or a BI tool or some other system that you're already using. And yes, in reality, that's what a lot of teams do today. They'll push a change, notice like an uptick in errors, and then ultimately accredit it to that change that they pushed earlier. And that certainly will give you some signal, but ultimately experimentation and the statistical rigor that it provides is what's going to bring confidence about causation, not just correlation. So getting into some advanced use cases, experimentation doesn't just stop at A/B testing. And once you get a hang of kind of the basics, there's a lot more you can do and a lot more creativity that you can bring into it. So a couple of examples include multivariant testing, where you're testing actually multiple changes of a single variable. So let's say you had 3 or 4 different versions of that sign up button that you wanted to test or something else. There's also multivariate testing, which is where you're testing multiple variables simultaneously. So in this example here, you want to test a blue button and a blue banner compared to a yellow button and a yellow banner. Now, similar to the guardrails metrics conversation we had earlier, in the case where you're trying to maximize impact, you likely have some KPI or success metric in mind that you want to optimize. Some examples might include click rate, conversion rate, email open rate, page views, anything like that. But in some cases, you might actually want to be decreasing a metric. So let's say you have a really high bounce rate on a specific page of your app. You might actually want to make improvements in the hopes of reducing that number. Now, you might have multiple success metrics also for a given experiment, or perhaps a combination of success metrics that you're trying to optimize in addition to guardrail metrics that you want to protect against. There's a lot of different combinations that you can get into here, and they'll likely vary from experiment to experiment. Another thing to consider is that as you're building your experimentation muscle and culture within a team, it's really unlikely to be one and done, where you'll have one experiment that magically improves your KPI drastically, and then you kind of move on to the next thing. In reality, you'll probably run multiple experiments over time to really improve and optimize that KPI, and not all of them are going to be successful. And that's actually okay. In fact, most experiments that are run end up being inconclusive. But ultimately, the data and the learning that you get through that process, that's really a success and a win in itself. All right, so once you run an experiment and that experiment is completed, what's next? Things don't stop there. Experimentation is a continuous process of learning and iterating, learning and iterating. But some sample outcomes might be one on the left there, you see that you've met all of your success metrics, you're not triggering any of your guardrail metrics negatively, you get to ship the feature and you actually celebrate, right? This is a success and you've gone through an approach that is truly data-driven. Or you might find that your results are inconclusive. And again, this is the most likely case. But through that process, you'll have some data and learnings, and maybe that informs you to go and actually talk to users, do some user research, and then you can use that combination of quantitative and qualitative data to inform your next experiments. Or perhaps the feature that you released actually led to an undesired impact. So you decide to scrap it and try another experiment in your toolkit. Again, likely you'll have multiple experiments that you're trying to run in order to optimize whatever that output is you're going for. Ultimately, building a culture of experimentation can be really valuable. Companies like Meta, Microsoft, Airbnb are running hundreds or thousands of experiments per year. Some of those experiments may impact the company's revenue in a very big way or lead to major cost reduction through like performance improvements, but that's not always the case. And more than likely, it's going to be an accumulation of multiple experiments over time that ultimately get you to that end state that you're trying to achieve. Now I'll hand it over to Mansi, who's going to talk through a real example of how we use feature flags and experimentation at Split.
Thank you, Annie. So we'll be going over a case study which I had done as a part of my experimentation in the data infra team. So we had a pipeline which was used for S3 inbound. So it's a service in which we can like send huge amount of data to that of the Amazon S3 bucket. So it's like a customer can put in data and like we take that data from the customer and like process it in Split. So the problem what was happening is that we suddenly started getting huge amount of data from our customers and we could not like balance in scale. So in order to kind of like improve scaling, we had to like increase our costs, that is run bigger and larger machines in parallel, which is obviously not something that is recommended and like is very costly. So we looked to kind of like improve our pipelines and we designed a new pipeline called as mentioned over here as pipeline 2. That is new pipeline and our existing pipeline which we already had. So we used an SQS queue, which is again something in AWS, is just a queue through which like we were able to detect when a customer put data into a bucket for us to kind of like grab that data into the pipeline. So in order to kind of like do a test, and so we want to like do a test and see how the new pipeline performed. And that also we wanted to ensure that we don't end up like having any issues with that of like customers who were onboarded and also how it would scale under the traffic which was currently there. So we decided to use a split. So what the split helped us to do was to divide the traffic over the two pipelines. This helped us to also kind of like help in terms of like get the cost analysis done. So we could A/B test, that is existing pipeline versus the new pipeline. What would the cost difference be? And it also helped us to kind of like test the new pipeline against the current production load. And one good specialty about Split is that if anything happened, we could just like shut down the new pipeline or just like kill the Split, and that would send the traffic directly to the next or the existing pipeline. So there was like almost like zero risk for any of our customers that we had onboarded already onto this feature. Next slide. So these are some of the results that we saw after like rolling out the pipelines in parallel. Uh, so when so we observed that the new pipeline scaled as expected under the given production load. With the help of Split, we were able to like increase as well as decrease the traffic that we received in production. So that was a very good test for kind of like seeing how the new pipeline kind of like worked in production. Then we also checked out like so at the end, we did conclude that our yellow, that is the new pipeline, was performing way better than that of the existing pipeline. And so you can like, so then we were of the opinion, okay, now how can we get new customers who are on the existing pipeline onto the new pipeline quite safely? So we had the set targeting rules part, which is in Split, in which you could just directly add the organization ID, and we were able to like very easily move customers from the existing pipeline to the new pipeline. And this literally saved us like almost 80% of the cost that we were facing, and it scaled really well in the given load. So next slide. And now this is the blog. You can read more about the blog. And there are many more case studies which were done not only by us, that is people working here at Split, but also people out there that's our customers who use Split almost day in and day out and kind of like get a very good sense of the metrics that we kind of like give out. Now, next slide. And now I'll be just going over a demo. Let me know if you can see my screen.
I can
So,
see it.
okay. So this is a Split Reservations website. It's actually a kind of like a reservation website, same thing like that of Kayak or Expedia. So here is just an example in which we have already pre-configured a Split in this website. And we would, as a part of an experimentation, let's like assume like we want to see what is the effect of having this more info button showing us the data and not showing us the data. So if you're looking at this website and we uh, assume we want certain users to be able to see the more info button. So basically, if they log in, they would be able to see all of this data, that is room facilities, the room facilities, room size, bed size, taxes, prepayment. And what if, and like 50% of our customers would not be able to see this. For this, like we have pre-configured a Split inside our rollout board. So this is a rollout board in which we can look at the various life cycles of the Split. So we have pre-production, 0% production, internal testing, external beta testing, ramping up, experimenting, and release. So our Split is in the released state. So now let's go into the front end, show more info. So this has last received data like an hour ago. So let's like look inside this Split. So this Split is configured to serve two treatments, that is show more info, that is show the text that we saw, or do not show more info, that is they have to click on the more info button and they can see it. And this is targeted to like 50% of the users. So 50% of the users will see this and 50% of the website users will not see this. And by any chance, if this Split doesn't work, it will default to kind of like not showing the text. So let's have a look at how it looks if a user logs in and doesn't not have, I mean, like is able to see the more info button. So it'll be something like this. that is the user logs in and the hide info button is already opened up and they can see all the data, that is room facilities, room size, bed size, taxes, prepayment, and so. So now let's go with the metrics impact tab. So here we can see an experiment. This experiment was running for like 76 days, 4 hours and 14 minutes, so almost like 2.5 months. And we can see some metrics that were already pre-configured on this split. So we have 8 metrics which are showing a desired impact and 1 metric showing an undesired impact. So let's filter on the 8 metrics that do show a desired impact. Here we see that bookings per platinum users have rised up. Bookings per user has also gone up and average booking price per user has gone up. So this experiment seems to be almost like a success. However, we do have one undesired metric, that is the average session length per user is lesser. So it seems to be the situation that the user just comes in, he gets all the information he needs like room facilities, room size, bed size, taxes, and prepayment, and he just goes ahead and books because he knows all his information upfront. So that kind of like gives probably a better idea to the user to kind of like buy more from this website. So from this experiment, what we can conclude is that yes, it's awesome that like if we can just open the hide info button, we can increase our revenue, awesome revenue impact. But the user may not stay long on the website, but that's okay, probably something people can do it. So that's how we can like conclude from this experiment. So that's about it for the demo. So I mean, like, any questions?